ladies and gentlemen, Agile practitioner, Agile pioneer, lecturer, author of books, and speaker at various conferences. Also here, a friend of Agile Lithuania community, because this is not the first time we have Tom with us. So really pleasure to have you, Tom, every time. In year 1976, way before the Agile Manifesto events in Utah, Tom has released his book about doing projects in small iterations. Therefore, sometimes we refer to Tom as Agile Uncle. Ladies and gentlemen, Tom Gilb.
Thank you very much, Lemolas. Okay, so first, not the last opportunity, but the QR will give you the slides. And you will want to do that because I have quite a lot of detailed references to free books and literature. Okay, but I'll also show that towards the end. And take a photograph of the screen. And then my what I call my Agile Library, everything I've written of slides and papers and books and videos about Agile, you can access it through this QR. So I'll give you a moment to do it. So 1976, I'll give you a quotation from that. While we have this book here, Principles of Software Engineering Management from 1988, which you can still buy. It's not out of print yet. It discusses Agile in depth under the name Evolutionary, Evo. Anybody who requests a digital chapter of the history of Agile, chapter 15, I can send it to you digitally, get a part of the book that way. Unfortunately, I can't give you the whole book digitally. We don't have it. Okay, let's see, anything else on this slide? Okay, so I'm going to focus on value stream management, and but in the Agile sense. And here's a subtitle, I'll read it. Estimating and measuring. I'm a fanatic on software metrics. Multiple, meaning 10 qualities, 5 costs, etc. Sprint delivery, stakeholder value impacts. That's a real mouthful, isn't it? But study it, think about it. We'll go through it in the talk, okay? Now, here's an overview of the talk with another chance to get the slides. I'm not going to read through that, but and I'll give this overview towards the end, but this is what I'm going to cover, which is very dense. But the point is, hopefully at least one of these things will tickle your interest, and I will give you links to follow up and go into more detail on these things. And maybe some are interested in scaling, some are interested in defect prevention, some are interested in digitization. I've got a little bit of everything here. Why do we need the methods I'm talking about? Well, to make a long story short, if you ask some of these tough questions, how would you do this with your Agile method, of this size and this complexity? Well, I've had to do that. And so long story short, my methods are designed to handle rather large, rather complex systems, is the long story short. And I've been doing this since the 1980s, is one at Siemens, is one reference there with 1,000 software engineers. Okay, now, here's the quotation from my software metrics book, which I'd almost forgotten that I'd written it, being so long ago. But on page 214, we find the following, and I'm going to read it. A complex system, are you listening, Dave, will be most successful if it is implemented in small steps, today known as sprints. I'm sure you all know. And if each step has a clear measure of successful achievement. That's something Joe Justice and Tesla speak a lot about, by the way, if you start looking at what they're doing. As well as a retreat possibility to a previous successful step upon failure implicit of that step. In other words, this is actually a recipe for projects that never fail on a large scale. You know about any projects like Titanic that failed on a large scale? Okay, so if you incrementally deliver successfully, hit a problem and get into reverse, get back to a successful point, and then continue progressing with success, you cannot fail. You will deliver success early, incrementally. You will deliver a value stream or stream of value. And I use the definition a little bit differently from lean people. Then you're guaranteed, you're guaranteed that you will accumulate success. And this may go on forever with no particular end. As Deming says, there is no end to the PDSA cycle as long as you're in competition. The competitors always try to up the game. Elon Musk says things about that too, which I just was reading last night. Okay. Yeah, I published that after I had 16 years of experience in 1976. I did my first Agile project, step-by-step delivery from 1960 and in the 60s, and just found the method worked. But I didn't have a name for it, except later began to call it evolutionary value delivery or evolutionary stakeholder value delivery. Okay. Right. Point number one of about 15 is this, that we got to move away from the predominant model. Who was it? It was Merrick yesterday who pointed out that he believed that about 11 of the 15 signers of the Agile Manifesto were in their heart programmers. And that shows a little bit too much. And the problem is that code cannot exist in a vacuum. It depends on data and hardware and networks and people and psychology and laws, et cetera, et cetera, et cetera. So fact is, everybody listening, we have to have a systems model, okay? And I'm gonna add, we have to have not only a systems model, that is include all these things, but we have to have a systems engineering model. That means we have to quantify and be systematic far more than we're doing today. And even my book in 1988, I was going to call it something like systems engineering, but my publisher said, no, call it software engineering. There's a bigger market for good advice there. But in the 2005 book, which you can have a free digital copy of right there, competitive engineering, it does say systems requirements and software engineering management. So I finally got systems engineering in the title, but everything I've always done has been about the system.
Tom,
again,
I'm sorry, I have to interrupt because I feel like your screen sharing is frozen. Can you try to reshare? Because I still see you on the first slide. I may be the only one, but
okay.
I'll
tell you what, I will
try to share again.
Okay, good. I will stop share and then just sort of redo it.
Mm-hmm.
Share screen. Okay, there we go. Okay, apparently I'm sharing.
No.
Do you have?
Okay, yeah.
The new slide?
Yeah.
And
can you try to switch the slides just so to make sure that it's live? It's not.
Yeah, I have to go to play. Let's see.
Okay.
I'm going back and forth between two slides.
No, I only see the slide. Maybe you can do without clicking the.
There's something called resume share here. Let's see, resume share. Yeah. Sharing is paused. Bring your shared window to the front.
Yeah, maybe you can do it without full screen. That would work, I guess. Unless you have fancy animations, but I don't believe it.
Oh, never had this problem with Zoom before, but Okay. Keynote we have to keep there. Okay, so can you see the screen now?
Yes.
Now, if I, let's see, if I'm going to play, does it move now?
Nope. As soon as you click play, that gets frozen.
Okay, well, we'll have to work around that, won't we? Okay.
Maybe you can just do slides without going full screen.
Yeah, I will do that.
Thank you.
I will do that.
Okay,
so repeating here, this is just my exhortation that we IT software people with maybe a programming background, we need to do real software engineering. Now, I say real because software engineering was used as in order to say the words programming from 1968 at the NATO Science Council conferences. They just decided to call programming software engineering. I mean real engineering for software and systems. And in order to do that, we have to include all those things that our software talks to, like people and data and laws and things like that, and culture. Okay, that's my point. So again, we have to be able to design and architect our systems. So this is about the same thing, systems engineering, but now I'm introducing the idea that I've written a book which you can have for free called about systems architecture. And it explains how to do agile and architecture. And most of you will know that the agile we know hardly speaks about design or architecture at all. But we know that small-scale systems just need a good craftsperson, a soft crafter. But large-scale systems we know need engineering and architecture. So I have spelled out exactly how I would do it using my methods in this systems enterprise architecture book. And if you want to know more about systems engineering, I recommend the INCOSE site. I've been a member for decades there. It's a recommended place to learn about systems engineering. Okay, so let's see. So next slide. Okay, now I'd like to introduce the idea of stakeholder engineering. I've long been fascinated by stakeholders as opposed to customers and users, or as opposed to the most important thing is to deliver working software to the customers in the agile phraseology. So customers and users is too narrow. There are in any even fairly small systems a great many stakeholders, and stakeholders are defined as people or things that have requirements. Okay, they hold a stake. And here's a little model of what I mean by stakeholders. Okay, stakeholders are even antagonists, like the enemy and hackers, people like that. And it's important to take them into consideration in your requirements. Let's say your security requirements would be dealing with these. Okay, so I believe you all need a phase of analysis for requirements, which includes deep and continuous stakeholder analysis. Who are the stakeholders? Who are the critical stakeholders, the ones that have most influence on our project success and failure? And what are their needs? And then you convert these needs into requirements, some of which you can't afford to deliver, some of which you will deliver. So here's a set of symbolic needs: accessibility, adaptability, criticality, intelligibility, etc. And so the stakeholders deliver you information that becomes a set of needs. I call these value objectives. And then based on that, you will come up with some strategies symbolized by the light bulbs there, some design ideas. And by implementing the strategies, you hope the value will flow, if you like, back to the stakeholder. Okay, so I think time for the next picture. Okay. Actually, I want this picture. So here's the value stream. You've analyzed that the stakeholders want or need, and you intend to deliver a set of values. By the way, simultaneous, parallel set of values, not just one, like bug-free or reliability or something like that. But you have to simultaneously, by the way, I often call these the top 10 critical values, meaning that if you delivered all except one, your system might still fail because it's critical. Okay, so we have to worry about all of these values simultaneously. And anyway, by delivering these strategies step by step, the value stream begins to flow, the stream of values begins to flow back to the stakeholders. Okay, got the picture? And you have to manage maybe 50 stakeholders, and the top 10 and below the top 10 are subsidiary values. So you may be managing 50 to 100 values in even a medium-sized project, not to mention a large one. Okay. Point 4. I want to emphasize this idea of the simultaneous multi-value, multi-cost requirements. Okay, most of us have fallen into the trap of staring at the user stories as the thing to be delivered, as the strategy. Actually, it's an ingenious mixture of identifying a stakeholder as a chief technical officer. I want X, that's a stakeholder. And often it gives the reason, which is actually the requirement badly stated, because of security, I want to do this. And then I want to do this in user stories is actually the design. So that's great for small systems. In fact, it's ingenious and it's advanced for small systems. But as you scale up to, for example, a government health system, National Health Service or something like that, you need to be more quantitative, and you need to be more systematic about the values and the strategies and the stakeholders. And that's my message. Agile was maybe born into people doing, Ron Jeffries' project at Chrysler or something like that. And wasn't really built for example, large government systems. But everybody's, of course, trying to scale it up, as we know. I want to introduce the idea of an agile efficiency measure that when choosing any strategy or architecture, we're not only looking to make sure that it is the design or architecture is powerful for our multiple measures of value, but we also want to make sure that it's different cost aspects, like technical debt. Surprised you, huh? Capital costs, ongoing monetary costs, portability costs. We want to make sure that those are as low as possible. And that's something else we don't see much of in conventional Agile, is consideration of various types of costs: time, people, money. But also the short term and long term. We tend to focus on the short term, like time. Will we make the deadline? And maybe will we have enough money? And that's it. And of course, in the long term, that leads to failure as we get to a stage where we have enormous technical debt, and we have to build the whole system anew to get out of the technical debt. So now the idea of the set of values we deliver over the set of costs, I call efficiency. And when we're playing architect, we're looking for the various architecture ideas which are efficient. That is, they give the most bang for the buck, or the pro for the quid, as the British or Latins would say. So, and again, I think there's too little focus on multidimensionality, the many dimensions of qualities and values, and the many dimensions of costs. So we have to tackle that. That's, of course, more difficult than doing one dimension, but it's also more realistic and more necessary for survival. Okay. And then on making choices, we need to say, how cost effective is this architecture? How cost effective is this strategy is the question. Now, I have developed a tool I'd like to give you all, and you can read up on it in detail in the architecture book I just gave you a free copy of. It's called an impact estimation table, and I'll only give you the simple, quick version of it. On this axis here, in the requirements, we have our multiple requirements, which are quantified, and we're moving from benchmarks or bases, and we wish to get to a certain higher level of improvement, and that's all spelled out in far more detail than you can see on the screen here. But these are our multiple values of our stakeholders. We also have multiple cost or development resources ideas. Let's call them budgets. Okay. On this axis, we have various bright ideas, the light bulbs, various strategies or designs or architectures. And then this little bar chart here is an estimate or a measurement, could be either one or both, of how powerful is health architecture for moving us towards our collect information goal, moving from 50 to 90, okay? And in this case, the estimate is 13%, which is better than zero, better than negative, but not very impressive. This architecture seems to be evaluated or measured as moving us halfway between 50 and 90, by the way, okay? So this is an impact estimate, and it's estimate in terms of the percentage of the way to the goal on time within budget. But as you see, we have a way of looking at multiple strategies in terms of multiple values, any number, and also with regard to their multiple cost aspects. And long story short, we can sum up this stuff and let us spread in a spreadsheet, for example, and perhaps spell out the most promising set of values for a set of costs, at least optimistically, before we bring in risk analysis, the quality of the estimate and things like that. Here's just the spreadsheet converted to bar charts, and we can see the various values, sums, okay, and the cost sums, and visually get a picture of how good is our architecture. So if you're interested in the tool, I recommend you read about it in the free book, Systems Enterprise Architecture, or the Competitive Engineering book, which is also free. But this is a great tool you can use all the time for looking at any two levels of consideration, including the requirements and the designs of anything, and making choices or prioritizing their incremental delivery sequence so that the highest value and lowest cost is delivered first. That's a very good agile practice. So here's just a diagram with where the arrows are. For example, this arrow means that I'm taking that architecture and I'm estimating how good it is for all of my requirements and adding up the sum. So I get a sum of the values and a sum of the costs, and can get a rough idea. This is rough modeling. It's not perfect modeling, but I get an immediate rough idea of the value to cost ratio. Okay. Number 6. Let me introduce you to people. I'm quite surprised that so few have heard of this, even people from IBM. But this is an internal process used at IBM Federal Systems Division, who was, after all, a software house. And they delivered to space and military customers. And they had a problem. Every time they won the contract with the lowest bid, they lost money on it. No surprises there. That happens on the lowest bidders, almost doomed to lose money. They've bid too low, but they got the contract. And IBM said, we can't muck about with that. We earn too much money other places. We either earn money on federal contracting or we get out of the business. And they went to a guy, I call him the Leonardo da Vinci of software engineering, Harlan Mills, and said, you're the smartest guy in town, Harlan. Go forth and solve the problem of always delivering to the highest qualities for space and military systems with the most complex, latest technology for military and space systems. Like one of their systems was the shuttle ground software, take an example, and make sure that we deliver on time so we don't get penalties and bad reputations, and make sure that we earn money on it. We earn, that is the fixed price covers our profit. He did so internally. He published it in IBM Systems Journal. The reference is down here at the bottom. It's ported to University of Tennessee, but you can get the original papers there. Now, there's an agile story here because his successful method known as clean room was agile. And I published that as early as here, 1988, which is maybe where some of the agile people like Marek claimed he had this book and had read it thoroughly in our party session yesterday, okay? And most of the agile signers claim they read this book as inspiration for agile. That's why I'm the uncle or grandfather of agile. But so I published it there. But for example, on one project, the LAMPS project, which went to a ship, a military ship, they did monthly increments for 4 years. Okay, so let's just, it was a total of 43 increments. So that sounds very agile. But more interestingly, when they try to explain how did we always deliver the highest quality demanded by NASA and Department of Defense, on time, under budget, every time, years in a row? And the answer is agile, but not the kind of agile you're using. This is the new kind of agile as it should be. This is the agile I described in 1976 in the Software Metrics book, which measures at every step and reacts at every step. If it's a failure, go back, get new. So what they're doing here, long story short, you can analyze this flowchart of theirs in your own time. But at every step, they say, did we get the availability increase we were expecting from this step? Yes, no. Yes, good, move on. There's a second question. Did the step only cost 1 month? No, it cost 3 months to get the availability. Aha, we have too costly an architecture. So if the cost was too high, or if the value was too low, their chief architect, Robert Quinnen, stepped in the middle of each step, and he re-architected, he redesigned. He found something that had more effect and or lower costs. And then they tried it out in a future step to prove it worked or not. Okay, and that's what my Agile, Evo, has always done. But, and by the way, I worked with these people quite personally for years on end. I'm not just reading the book there, but I made annual trips to their labs and talked Harlan Mills into coming to Norway once for a conference. So, okay, so long story short, we have a large scale proof long before the Agile Manifesto in a book which inspired some of the Agile Manifesto signers, saying that this step-by-step, but measurement and redesign is a very successful project management idea. And what's surprising is how few people, like I'm always asking professors who are teaching students, do you know about this method? Do you teach that it exists and it still exists and is being practiced by people all over the world? For example, Hewlett-Packard and Intel adopted my Evo, which is very similar to this, and spread it throughout the corporation. So it lives on. I think people at IBM have forgotten it because Number one, IBM Federal Systems Division never marketed and sold it. They weren't, as Dave Snowden was talking about, in the business of selling software and methods at the time. So they just published it, you know, as internal methods, do what you like, but we're not going to give you a certificate or sell it to you or anything. That's probably why it got forgotten. It wasn't marketed the way agile methods are marketed today. Interesting. Go study it detailed. Okay, so here I mentioned one of my favorite clients is Intel. Here is a research paper done by an Intel man, John Terzakis, and what Intel did was they adopted my planning language, my Planguage, which is described in the competitive engineering book and in this book in detail, for specifying requirements and designs and things like that. And they actually had within a 20-year period, they've been using my methods. They have trained 2 or 3 day course, 20,000 Intel engineers in Planguage, okay? And they haven't found anything better for 20 years, so they're still using it. But what John did is he started doing some interesting research. And so he has some nice quantitative examples. So look at this one. This is a requirements for a chip of 31 pages being handed into a process you'll find in my competitive engineering book called Specification Quality Control, Spec QC. So they are quality controlling using my method, my planning language, which they're using to specify their key products. And they found that they had a defects per page of 10. Now, actually, that's pretty good. If you analyzed your requirements, you would have 100 defects per page or more, up to 700 or more. So I credit on loose evidence that the use of Planguage, being a clear, quantified, structured language, immediately leads to a high quality set of requirements, only 10 defects per page. By the way, page is 600 words, in case you wondered how big a page is. Now, it turns out that's good enough for many people, maybe most of you. But at Intel, they have extreme quality standards because they're going to freeze all their logic on a chip sent all over the world. And if they had to have a recall of that, it would break the company. So they have studied and found that they have to have 50 times better quality. By the way, quality means here intelligible to the architects, programmers, and testers. Enhanced security would have 2 defects, the word enhanced and the word security not defined. Getting messages from Agile Tour here. Okay, now, in their wisdom, they found that the economic level of quality for requirements is 50 times better, or 98% better. It's 0.2. So what they do is they say, sorry, guys, your document ain't good enough. Follow the rules for Intel's extremely high quality code. By the way, the rules are taken out of my book, Competitive Engineering. You can go and get them there. But they say things like requirements should be unambiguous and clear is a mainstay. And come back. And so they do, and they only have half of the defects, okay? And this continues, they're still not getting it until about the 6th iteration. They have a 45-page requirement document, which in total only has 10 defects. Now, 45 times 600 is the number of words there. Only 10 defects, that's fantastic quality. It is no more than 0.2. And they say, right, we cannot go for 0 because that would be infinite cost, but we'll stop here and we will publish it and exit it and send it on to presumably the architects and testers and people like that. Okay, so by the way, this is upstream defect prevention. If you look at anybody's analysis of why do we get bugs and why do projects fail, number one is always bad, sloppy requirements. So Intel is dealing with the bad, sloppy requirements upstream, and they're not permitting us to go downstream to architects, testers, and coders until the quality is 50 times better than submitted, not to mention 7 times better than other people would submit if they weren't using Planguage. Okay, so next, that's a pitch on defect prevention, preventing the defects from getting downstream. Okay. Let's see, look at my timing. Okay, I have more time. Number 8, the point I want to make here is that when you have this table set up with evaluations of how good is this architecture, how good is this architecture, what does it cost, you can compute the priority. If you make a decision like whatever has the most good effect on my values at the least cost is my priority. What does priority mean here? It means if you have choices, this or that, it means you're going to choose this one. If you say, well, I might do all of these sooner or later, but what should I put in my early increments? And the answer is you should put in your early increments the highest value, lowest cost item. Sound like a good idea for Agile? How do you decide in your Agile what the next increment will be? Do you have clear quantified objectives and cost budgets? Do you use them to evaluate how good is a potential increment? And do you choose the increments that have very high value, low cost ratio and do them first? I doubt it. Okay, and I think if it's about time we started doing this as the norm. Okay, so you message here is you can't, using the impact estimation table idea, you can compute priority at every increment. Now, what that means is, even if some of these estimates are a little bit disappointing, it isn't quite as good as people thought, and even though some of the costs are somewhat more than you dreamt about, you'll probably have fairly successful, fairly cost-effective steps, okay, even if there are disappointments, okay? So you'll look good even if there are disappointments. And you might like to know, how do I look good? By delivering real measurable value to stakeholders in each and every increment or sprint. That should be the Agile question. Number 9, every time I see yellow stickies, and I saw a lot of them in Joe Justice's videos yesterday, I groan. I see the point at a certain level, but long story short, and by the way, it is number 5 on Elon Musk's list of things we have to do. It's called automation, okay? It's time that all of our planning, requirements, and design did not reside on handwritten yellow stickies. It is all digital, okay? And we keep track of every little detail, all those stakeholders and all those needs and all those requirements and all those tables. We keep track of them entirely digitally, okay? And so, lots of things happen with that. I just think yellow stickies is an outmoded small scale method. By the way, at certain stages for certain purposes, yellow stickies are fine, okay? But there comes a point where they've outgrown their usefulness. And me, I never, ever use yellow stickies, never have, never will. I always go directly to a good digital tool and start planning anything and everything on hour 1, day 1 of anything. That's my bet. But I'm encouraging you to think that maybe yellow stickies aren't the digital transformation that you're talking about. Ha ha. Well, we're all busy discovering that the early Agile methods had problems in very large scale enterprise solutions. So everybody's trying to scale up. I was looking at some of this scaling up a few years ago, and I looked at it and I was not impressed. I didn't like it at all. I didn't think it was good at all. So I started and I basically, not surprisingly, felt that my methods were better than anything I saw, like SAFe, for example. SAFe has just stolen some of my methods without credit, but they promised to restore the credit. So I started writing about it, and I then sent the paper to my friend Eric Simmons, who's the man who made the 20,000 people at Intel use my methods over a 20-year period. And I have great respect for Eric. Eric, of course, is in the Gilb Fest Club and plays fantastic organ pieces. Anyway, and he said, Tom, your methods do not scale up. And when I read that email, I thought, oh my God, I'm exaggerating about how good my methods are at large scale. And then he continues, and basically he says, actually, Tom, your methods don't need to scale up. They are scale free. They are not dependent on project or organization size. They're good heuristics for almost any project and nearly universally applicable, etc. So you can read about that, and there's much more there. And so somehow, without deciding to do it directly, in my 50, 60 years of developing these methods, I have chosen things that work at any scale. Now, remember, I claimed in an earlier slide that in 1980s, I was at Siemens with 1,000 person projects. So I was dealing with very large projects very early, and my methods did work there, and they had to work under any circumstance. So maybe I kept the methods that worked in practice with my clients and threw away methods that didn't scale. I don't know. So, but here's an idea. The idea that there is a set of methods, mine and hopefully other people can lay claim to it. I challenge anybody to write a paper about other methods that are scale free, but I've written my papers. Here's an IEEE paper published July, August this year about scalable requirements, IEEE software. And the editor of that, Sarah Gregory, who edits that column, is also one of the people who worked with Eric at Intel, and she says nice words about my methods at Intel in that article. Okay, so in other words, we know that some of the methods we started using were not scale free. In fact, didn't work at large scale. So we went on the big hunt and ended up with SAFe, which Dave correctly said was the sign of the end. The end is nigh. The end is coming. Let's see, how's the timing? Okay, might not have that much time for questions, but I do have a couch session afterwards. Now, number 11, Lithuania, like Norway, isn't a very big country, even though, because we're so small, we have some very big national systems which cover the whole country, like our health system and things like that. But I thought I'd, and the Intel projects aren't that large. You know, they're often just a 5-person team developing a new chip, but there may be 100 or 200 such activities spread around the company. But I thought I'd give an example of small scale, and this happens to be in Norway, and it's a company thriving today, but they started using our methods 2003. Okay, in the early days of Agile. And they succeeded wildly. In the first few months, they managed to deliver such high qualities using these quantified multidimensional methods in 4 parallel teams of, in total, 16 programmers, 13 programmers, 3 testers, really, that they captured the international market and destroyed their competitors like Pulsetrain, 100 people in Britain that they took over, and we went and trained them in our methods there. So this was very quickly successful in the market, and they constantly credited in public the use of Evo, my Agile method, and the Planguage as being the key to letting these wonderfully well-educated engineers. Turns out everybody on the team was a graduate of the Norwegian Trondheim Engineering College. And I've always learned that people who like my methods have an engineering education and culture, and people who don't are not engineers and they don't want to know about numbers and systematic thinking. They just want to code. So no hope there. So, but I thought I'd point out this successful, well-documented, small-scale example of using the methods. By the way, here's the impact estimation table on a spreadsheet that Trond Johansen made one evening, controlling the process. Okay? Red, green, yellow signals giving priority. This is something that Joe Justice mentioned that they use. I think it's at Tesla or in looking at their whole process. I even suspect they picked up that idea from me, but I have to confirm it with somebody. So winding down, I wrote 12 principles. Now, looking at my timing and looking at the principles and knowing I should probably use a whole hour to explain them, I won't go into detail. But we can start with this idea that the critical improvement objectives must be quantified, and continue with the idea that the strategies, also known as architecture design, must be estimated for its multiple impacts. And then if you have bad specifications like at Intel with 10 defects per page, you need to reject them or not exit them, have a discipline in quality. And there's more, but if you want more detail on it, I want to give you another free book, or if you don't like to read books, I'll give you my slides. And if you don't like to read slides, I'll give you a video of Value Agile, a book I wrote in 2020. So, and so by the way, that at LeanPub, we're selling it cheap, i.e. You're $5 to $10, free sample of half of it. And if you're a poor student and you can't afford it, email me, I'll send you a free copy. But free copies are essentially available in the slides and video for the ideas anyway. So, okay, but that's where we go more deeply. By the way, in Value Agile, I analyze in depth the Agile Manifesto, and I criticize why I think it's mainly bad ideas, with few exceptions, and then I suggest constructively some better ideas. So if you want to look at an analysis, my analysis of Agile Manifesto, you will find it in this free, almost free book. Okay. This summer, I wrote a book for, Dave mentioned the idea of sharing his ideas open, and an idea I'm very much in favor of and always have done. And so here's another free book. My old friend and enemy, Ivar Jakobsen, runs an outfit called Essence, and Essence is devoted to sharing methods and methodology. No more frameworks and certifications. All methods are freely available, if you like, in a database, and people pull in any methods they want at any rate they want and tailor or build their own method set. Very interesting idea. And so to make a long story short, I said, Ivar, I hereby donate all of my methods, which are arguably hundreds. And to make it easy, I wrote this book this summer called Simple Planning Language, and it divides my methods into about 120 micro acts or micro methods that can be pulled in independently. So if you think my methods are overwhelming, here's an opportunity to pull in one at a time, absolutely free, and see if it works. And if it works, keep it. And if it doesn't, reject it and try something else, maybe from somebody else, in essence. Anyway, the book is free right now. And here's an overview, like risk management, prioritization of some of the topics we're doing. And there's a link to Essence for anybody else. Maybe Dave would like to give away his methods to Essence and not put them on the open thing. Anyway, one of the great supporters of Essence is a man called Jeff Sutherland and Scrum. You might be interested. I was surprised, but it's there. So now I mentioned stakeholder engineering, and long story short, just after the Gilb Fest, I did what I've been planning to do for years. I wrote a little book on stakeholder engineering. Here it is, and there is a free link for you. There's the paid link for your friends. Okay, but if you want to go really in depth about stakeholder engineering, have a read. I'm very proud of finally having written the book I talked about for years I would write. Okay. Here is the Elon Musk 5 principles from these videos, starts there. And then this is just a text, the videos from, I think it's January, published on Every Day. It's fantastic walk around for 2.5 hours with Elon Musk spouting this and that on the SpaceX platform. So I watched all 3 videos right away. I think everybody did. And then here is his philosophy he stated several times. He also stated that sometimes he violates his philosophy and he does things in the wrong sequence, like tries too much automation of Model 3 cars too early and goes back and realizes he should have done these things better. Okay, but so he gives a sequence. It says you have to do these things in sequence, sort of master each one by one. Here's getting the requirements good. Here is simplification. Here's optimization. Here is acceleration, right? And here finally is automation. So I couldn't resist analyzing how what he really meant, because he just spouted this. Unmute. Have I been unmuted long? Okay. Let's see. Okay,
Yeah,
so we're
you have been unmuted for a minute.
Oh dear. Okay. Well, here the most important thing is the paper on the analysis of Musk's 5 methods is down here on page slide 22. Important to get that in, so you can go and study that. And the videos themselves are right there. And the written source, which is done by the everyday astronaut, of what Musk said is in these words here. Okay, and they're quite interesting. Okay, so that's the summary. And actually, I've reached the end of my talk and can invite questions. I believe we have we got 6 minutes? What do we really have? I can't hear anybody reply to me.
Yeah, so we're here, and yeah, it seems we have some time. Let me double check how much time we have.
Yeah. And anyway, there's my email. And anybody who wants to send me a question, I will answer it. So that's an easy way to do that if you think of some afterwards or after having read the slides. We don't have to do, and I will be on the couch shortly, another place to do questions. And might be a good idea to read some of the detail, at least in the slides themselves, not to mention in the free books and papers I'm offering before you ask questions. In other words, here's another book. This is with a wave to the complexity ideas of Dave Snowden. I believe that the problem with complexity is not that systems are complex. They are. I believe that we don't have the tools to see and understand complex systems. We're like looking at the stars with our eyes, and we don't have a Galilean telescope, or not to mention a Hubble telescope, to see things better. So I've coined the term technoscopes, which are my methods for seeing complex systems, like the impact estimation table is a very good example of a technoscope for seeing and understanding a complex system. So for those who say it's a complex system, it's difficult to understand, I say, please read the Technoscope's book and apply those, then tell me it's difficult to understand, because I don't believe you. I believe you are lacking basic tools for analyzing complexity. Free book down there. Well, not so free, cheap. If anybody wants a book that is behind a paywall that I've written and they're a poor student, just email me. I'll send you a free copy. Were there any questions?
Yes, we have a couple of questions.
Ready.
So thanks, Tom. Yeah, a lot of stuff in your slides. So I think, yeah, it's useful for people to go through all those slides. And I hope you have uploaded your slides yet to our Google
I have.
Drive.
They're definitely there.
Cool.
And I gave the QR for the slides. Anybody can go directly to them.
Ah, that's great. Okay.
Yeah. So there it is. Sorry, can you see that? It says, oops, go back a slide.
Yeah, now we see that.
Yeah, okay. So there's the QR for these slides. Scan me. And there is my Agile library for anybody who wants to go into depth on all my Agile ideas.
Nice.
Yeah, so I'll keep that up there.
Okay. So we can go to the questions and answers part. So this is interesting question I see. Challenge, building Titanic incrementally. How can we do that?
Okay. Could I have the first name of the person who put the question just to be able to attack them later?
Yeah, he just left moderation of this track. It's Limonas.
Okay.
Who was introducing you.
Right, okay. Now, let me give you an analogy. If you study Joe Justice's many videos about Tesla, or you study the Musk videos that I mentioned right here, okay, you will find that the hardware known as a SpaceX rocket, which is probably bigger and more expensive than the Titanic ever was, and the Tesla automobiles, they are all on an everyday basis delivered incrementally. They're all changing at all times. Tesla is apparently the only automobile company that has, as Joe Justice says, has 27 engineering changes in production every week. That sounds like a DevOps stream. They're constantly analyzing and improving and changing at all times in their hardware, which is very complex, both at SpaceX and at Tesla. So long story short, to understand hardware, and I'm using this because the ship is essentially hardware, to understand how you might do shipbuilding, Elon Musk style. If Elon Musk were running the shipyards, I promise you there would be Agile all over the place, okay? In the sense of 27 changes to design or to engineering or to production every week for years on end, creating the growth of value like safety or entertainment quality to satisfy people like me. I'm driving my third Tesla, a Tesla 3. It's just wonderful and amazing in design. And I can see the differences in the hardware through the three Teslas I've had. So, but Joe Justice in his videos, if anybody can't, you should be able to Google Joe Justice Agile at Tesla, similar to the talk he held yesterday. And you get great detail on the agile evolution of hardware on an everyday basis. Again, Elon Musk is unusual in doing this, both in the rocket business and the car business, but he's proven it can be done. That's my simple answer. A much longer answer, I would have to develop how would we actually do it in shipbuilding, or how has it been done? And I think timing doesn't permit me to do that, but I'll have that argument or write a paper on it or something if somebody absolutely needs it done for shipbuilding. But the important point is that Joe Justice and Elon Musk have done it in spades. Read about it and then come back and talk about the Titanic.
Cool, thank you. And maybe one final question from me personally. So it seems like Elon Musk has read your books.
Well, I'd like to think that. But remember, he comes from Silicon Valley culture, and I have spent decades in Silicon Valley with Hewlett Packard, among other things, and my books have been published. So in my dreams, Elon has thoroughly read my books, and when we meet next time, he will say, "Oh, Tom Gilb, just like Marek did yesterday, I read your Principles of Software Engineering Management book many years ago, long before I started Tesla." That's my dream conversation. It hasn't happened yet, but it doesn't matter. Let's just say the ideas have been there. As I document here, the ideas about Agile precede me, believe it or not. They're ancient. They've been in many cultures. That's that chapter 15 in this book. So, Elon was subjected to good Silicon Valley culture, and maybe he got some ideas directly or indirectly from me. I don't care. I'm thrilled with the class of ideas he has today, what he does in practice. So read my paper, which analyzes what's going on here. Okay, making the requirements less dumb is what they did at Intel by analyzing the quality before they released them. Okay, and that's Silicon Valley, even though those guys who did it were in Portland or in Boston. Okay, so Elon's great. His methods are great, and it would be one day it'd be interesting if Joe Justice and I, and maybe an old retired Elon Musk, sit down to write down the details, the training course in his methods. Now, by the way, Joe Justice does give training courses in this, as he carefully points out quite frequently, his Scrum Master course. But we need to, I believe that these statements by Musk are a little bit too brief, and they contain a lot of implicit knowledge in Musk's head. That's why I wrote my paper trying to decompose it and make it more explicit, and I'm not finished with that.
Cool. Yep, thanks, Tom, for your sharing and for your caring. Seems like great people think alike,